David here with another question from topic 6.1. We're still looking at forces in circular motion. In this question we have a circular loop in a roller coaster. So the roller coaster car comes in off this ramp, does a loop, and goes out again. This is a vertical circular loop, and we want to add arrows to represent the forces on the roller coaster car at the bottom of the loop. So right here, what's going on? Well, this is a vertical loop, so the car is being pulled down towards the center of the Earth by its own weight. So weight is going to be one of those forces. But if weight were the only force, then the car would be accelerated downwards. But it appears to be being accelerated upwards. It's being pushed in a vertical loop back up. So there must be some sort of force pushing it back up, and of course that's the normal force from the tracks. The tracks are preventing the car from falling through the tracks and through the ground and into the center of the Earth. So there's an upward force from the tracks themselves, and that's the normal force. How long should the normal force be? Well, it needs to be longer than the weight. We don't know how long, but it needs to be longer than the weight, because it needs to overcome the weight and then still accelerate the car into a circle. We'll call that the normal force. So those are the two forces acting on the car. There's no force left or right, not at this point anyway. Part B, identify the centripetal force when the roller coaster car is at the top of the loop and at the bottom of the loop. Okay. Well, since we've already drawn the forces for the bottom of the loop, it might be easier to answer part 2 before part 1. So we might do that. One thing that we know is that whenever we're traveling in a circle, the sum of all the forces on the object must be a centripetal force. So the centripetal force is whatever the sum of all the forces is. And so if we look at those forces, we have the normal force opposing the weight, or the normal force is opposed by the weight. So the sum of all the forces is a centripetal force, and the sum of all the forces is the normal force minus the weight. So that's our answer here. The centripetal force is the normal force minus the weight. Now what about at the top of the loop? Well, this question doesn't give us quite enough details to give a perfectly correct answer, a perfectly accurate answer. But we'll do our best, and we'll look at the different scenarios. So there's the center of mass of the cart, say. And again, the weight acts downwards towards the center of the Earth. Now, the mass of the car hasn't changed unless someone got sick on the ride. So the weight will still be roughly the same length as it was down there. But what about the normal force? Is the normal force just like it was before up here? Well, no, I would suggest probably not. It does depend a lot on how this roller coaster is constructed. I suppose there are a few different possibilities. One possibility is that there is no normal force. One possibility is that the speed of the coaster is tuned just right so that when you come through the top of the loop, the weight is just right to provide the exact centripetal force that you need to curve into a circle described by the track, which means that your weight perfectly pulls you around the track without you actually being pushed into or against the track itself. Another possibility is that if you're moving a bit faster than that, you might need some normal force to push you down. So an additional normal force to push you down as you are moving so fast that the track pushes against you. A third possibility is if you're moving too slow. If you're moving too slow, then you're actually hanging by the track as you slowly fall around, in which case the normal force is supporting you upwards to keep you from falling off the track itself. So this would be if you're like hooked into the track and you're hanging from it as you slowly roll around. So 3 different possibilities. The normal force could be up, it could be down, or it could be nothing at all. So I think for our answer for this question, we really just can only describe the three possibilities. The centripetal force is just the weight, or the weight plus the normal force, or the weight take the normal force. And I suppose if we were being strict about our vectors, we could express all three of these possibilities as a single statement. But that doesn't seem to be necessary to me. This isn't an IB question, so it's not that carefully written. I see three different possibilities. Either the centripetal force is just the weight plus the normal force, or the weight take the normal force.